The next 50 years could bring humanity's most dramatic transformation since the Industrial Revolution. A new report by the Royal Society titled Space 2075 presents a stunning vision of what life in and beyond Earth's orbit might look like within just a few decades. Backed by cutting-edge research and current scientific progress, it lays out a roadmap filled with moon bases, space factories, asteroid mining, and even the possibility of human births on Mars. Since the early 2020s, space activity has rapidly increased. Thanks to technological breakthroughs like reusable rockets and low-cost satellite deployment, launching missions into orbit is becoming faster, cheaper, and more frequent. More satellites have been launched in the past few years than in the entire previous history of space exploration. This new space age is the foundation for everything that's to come. One of the most promising developments lies in microgravity manufacturing. Scientists have already begun experimenting with producing materials in space that are difficult or impossible to create on Earth. For instance, fiber optic cables made in space have shown far fewer impurities, making them far more efficient. In addition, pharmaceuticals and even artificial human organs are being tested in zero-gravity environments, the hope of revolutionizing how we treat disease and deliver healthcare. There's also increasing interest in building data centers in orbit, which could take advantage of space's cold temperatures for cooling and the unlimited solar energy for power. Asteroid mining, long considered science fiction, is being actively explored by multiple private and public sector initiatives. The asteroids that orbit close to Earth contain vast amounts of rare metals like platinum, nickel, and cobalt. With the right robotic systems, these flying rocks could become the fuel for future economies, providing critical materials for technology, clean energy, and space construction. One of the most exciting frontiers is space-based solar power. Imagine huge solar arrays orbiting Earth and beaming energy down in the form of microwaves. Unlike terrestrial solar panels, these space systems wouldn't be affected by weather or nighttime. Experiments have already shown that this is possible, and new trials are scaling up to test beaming higher levels of energy over greater distances. This could revolutionize global energy supply and offer a clean, constant alternative to fossil fuels. But not all developments are without risk. The growing number of satellites and debris in orbit has created a dangerous environment. A collision between objects in space could trigger a cascade effect, damaging vital infrastructure and blocking safe access to orbit. That's why researchers are now developing technologies to actively remove space junk, capturing and recycling dead satellites to prevent disasters before they happen. The potential for conflict in space is another major concern. As more countries and companies stake claims on the moon, asteroids, and orbits, the threat of territorial disputes and resource wars grows. The Royal Society emphasizes the urgent need for new laws and international agreements that regulate space use and ensure peaceful cooperation. Without them, we could see the dawn of a new kind of geopolitical tension, one that stretches beyond our planet. A particularly sensitive topic is planetary protection. Every spacecraft sent to another planet carries with it microscopic Earth life. When humans eventually travel to Mars, or the moons of Jupiter and Saturn, we'll bring trillions of microorganisms with us, some of which might survive and contaminate alien environments. Likewise, if we return samples to Earth, there's a risk of exposing our planet to unknown extraterrestrial microbes. Scientists are calling for stricter policies and better oversight to prevent irreversible contamination in both directions. Perhaps the most provocative possibility in the report is the idea of humans giving birth in space. Advances in space medicine and artificial womb technologies are opening up questions that were once left to science fiction. If a child is born on Mars or in orbit, what rights will they have? What citizenship? What kind of medical care and psychological support will they need? These questions don't yet have answers, but the report urges us to begin ethical and legal planning now, before we face them in reality. Automation and artificial intelligence are also expected to play a key role in the coming decades. Robots will be the first settlers on other planets, building habitats, mining resources, and preparing the way for humans. They'll also operate in environments too dangerous for people on asteroids, in deep space, and even inside planetary atmospheres. These systems will be essential for maintaining infrastructure and keeping future missions safe and sustainable. The economic potential of space is enormous. In the United Kingdom alone, space technologies already support a significant portion of national GDP, powering services like weather forecasting, GPS, communication, and environmental monitoring. Globally, the space economy is projected to exceed $1.8 trillion in the coming decades. But to capture this opportunity, governments will need to invest in research, education, infrastructure building, a skilled workforce, and a strong regulatory foundation to guide growth responsibly. Finally, the search for life beyond Earth is becoming more scientifically grounded than ever. Mars, Europa, and Enceladus are all promising candidates for microbial life. And upcoming missions are designed to search directly for biological signatures. If we do find evidence of life or even just the potential for it, humanity will be forced to reckon with its place in the cosmos. How we choose to interact with alien ecosystems, if they exist, could define our moral legacy for generations to come. In summary, the vision outlined in Space 2075 is not a far-off dream. It's a strategic, research-based forecast that aligns with real-world progress already underway. From orbital factories and solar power stations to Martian births and interplanetary law, the world of 2075 could look vastly different from the one we know today. But whether it becomes a story of progress and cooperation, or conflict and exploitation, depends on the decisions we make right now. The future is already in motion. It's up to us to shape it wisely.